Today, Open Source Security is talking to Brian Fox. He's a co-founder and CTO of Sonatype. Brian's going to tell us all about this, just, I don't know, scary or amazing, I'm not sure what to call it, report from Sonatype about open source malware. So Brian, welcome to the show, man.
Yeah, thanks for having me. Good to see you again.
Yes. I've known Brian for a long time, and he's been on the podcast more than once. So it's always a treat, for sure.
Yeah.
So I'll just kick it right off. So Sonatype has this report that came out at the end of 2024, and it's called
hmm
2024 in Open Source Malware. And in your bigger open source report, you had a little bit of information about malware in the open source ecosystem. And this report goes a little deeper. And so I'm really
hmm
excited to have you on to talk about this because this is something I feel like we don't talk about very often in this universe. So just set the stage for us. I'll let you kind of take it over from here and we'll see where we go.
Yeah, sure. Setting the stage. I mean, we got to go back a little bit to 2017, I suppose, is when, I kind of first had that moment of like, hey, what's going on here? So all the way back in 2017, there were a couple of things that happened. I mean, one of them was sort of a tongue-in-cheek blog that was sort of like, hey, I released an NPM component that's collecting all your credit card data and it's getting into websites. And at the time, it was like funny, not funny, because I knew that like I was afraid that that might happen. About 4 or 5 months later, we then saw a couple of attacks. If I recall correctly, the first one was on NPM, second one was on PyPI. What was new and novel about those was the attack itself was stealing data, attempting to lift credentials for open source publishers like you and me, of publishing open source components into those repositories and sending them off to Eastern Europe and I think China were those two instances. And, I had that moment of looking around like, anybody else notice this? That looked a little fishy to me because, prior to that, the attacks that we had seen, intentionally malicious attacks and things like that, were more like trying to steal cryptocurrency and or stealing the usual social security data, credit card data, these types of things, where the focus was on exploiting the end resulting product. But what was new and novel at that moment in time was that the attacks were focused on open source developers, and it wasn't trying to get into the product. It was literally a smash and grab, or maybe a better way to think of it, a phishing attack on open source developers, right? And so, we started really tracking that, and I started writing about it and telling everybody who would listen, this is a new problem and it's only going to get worse. So that was all the way back in 2017. And, for the last, as you know, we do that annual report. We've reported on this in early years. It was up hundreds of percent. It was doubling, for 3 years in a row. It grew 750% each of the 3 years, not over 3 years. Each year it grew 750% year over year over year. Last year, the number of these components was up 156%. And the latest number I have is there's about 820,000 components out there that have been published who have no legitimate purpose in life other than to cause harm. These are not vulnerabilities. These are intentionally malicious components, which is a very different thing.
Right. And we should
So
clarify,
that's,
we are currently at the end of February in 2025. And in Brian's
yeah,
report for 2024, I'm looking at the number here. It says 778,000, and you said it's 820,000 already in a
yeah,
couple of months, which
yep.
is bananas. Okay, so let me ask the first question before we dive into the numbers is how do you know this is malware? Like, how are we identifying these particular packages?
hmm I'm glad you asked that, because we have a really interesting and novel approach to it. So the challenge I had way back in the early days, I was talking to this, and we of course have, we've been providing SCA capabilities for like 15 years at this point. So software composition analysis, helping companies understand their components and when they have vulnerabilities and license issues and be able to correct them. Right. That's kind of where we had been before this. I mean, we still are, but that was sort of the background. And I was telling people about this, and we have a capability on, Nexus Repository Manager or Artifactory. We call it the repository firewall, where you can apply policies. And so you can say things like, don't allow my developers to pull down a new component that has a vulnerability in it, like a level 10 or whatever. You could block it before they even integrate it into their product. And so people were saying to me, well, this is great. You just scared the crap out of me with this information and showing them some of the specifics. What do I do about it? And I didn't have a good answer other than, put a policy in place that says, an N-1. You can't use the latest version, or you can't use a component until it's been out there for a week. Hopefully the community discovers it before then, right? That was the best answer. And it wasn't a great answer. But then there were some attacks that came out that had been lingering for 6 months. So it became obvious that there wasn't a good window of time you could wait for things to be declared safe. And so we started really looking into how can we figure this out? Because it's very clearly, as you know, a cat and mouse game. The attack vectors are constantly shifting. And what we recognized was that the problem space looked almost like credit card fraud detection, right? So in the old days, they used to publish books of blacklisted not IP number, credit card numbers, and then a little bit later, you'd swipe your card and it would dial up real time to check if that number was blocked. But that was still very reactive. They had to wait until a card was reported stolen or there was a fraud report before they put it on the block list. What they changed, a couple decades ago, and they continue to refine it, is more behavioral analysis. So they understand what's normal for normal users in general, and also each of us kind of, I think, get stereotyped. Like, I'm a traveler. When I first started traveling, my credit cards would, pop up and get blocked just because I was on the other side of the country. Now that doesn't happen because that's like normal for me. But what's not normal? Brian doesn't fly to the other side of the country or a different part of the world, go to a electronics place and buy 15 TVs. Like, that's not normal. And so I think most of us as consumers at one point or another have gotten a text saying from their bank, their credit card, saying, hey, an unusual transaction just happened. Was that you? And if you think about it, if the bank is good, most of the time you think about it and you're like, yeah, that thing I did is not something I normally do. So it kind of makes sense that they block it, right? So what we did is we took the same approach. We said, well, we can't always know what the new and novel attack is going to look like, but we can know what normal open source development looks like because there's millions of components. And so can we train a model on this? So all the way back in 2018, we started using, MLAI, machine learning types of algorithms to train on individual projects and the project space as a whole, and started using that to flag things that were deviating from that norm. And a really interesting story that kind of highlights the power of this approach actually happened. We were basically alpha testing this algorithm. We developed it and we didn't have it fully integrated in the product yet, but we were just kind of running it because we have a data team that is used to researching vulnerabilities, right? And so we said, okay, let's turn this on. If they find something, we'll send it to the team and they can figure it out. And what actually happened was we started flagging a series of components. Um, I feel like this was maybe 2019, maybe it's 2018. The COVID timeline gets things a little bit screwy there. But what we found was it was actually a white hat researcher. He left enough breadcrumbs that we were able to follow that and reach out to him. And it turned out this was actually Alex Burson. You probably know the name. Alex was the one who
Nice.
was doing what is now called the namespace, the dependency confusion, where he was publishing components into public repositories that use names the same as he knew internal companies. These are companies like Tesla and I forgot the list, Netflix, I think, and a bunch of big brand name companies, and was tricking their build systems into fetching his components. And so he collected a bunch of bug bounties, and that research was published somewhere in like the January timeframe. So 6 months before he published that research, our new and novel approach picked it up. Now, why did it pick it up? Because his attack depended upon publishing components with a high version number, higher than what their internal one was. So when their build system said, get me the latest, it looked across the source and said, oh, this version's higher, it must be the latest. Well, in retrospect, what do normal projects, not do? They don't start publishing to a repository with version number like 1000, right? And so after his research was published, lots of other companies produced algorithms that started looking specifically for that indicator. But we didn't have to because the system already knew, like, that's just not normal. We're going to flag all of them, right? And so we've continued to refine this over the years, but that is literally how we're able to flag these things, because we can understand abnormal behaviors. Things like really popular projects don't suddenly become the first user of this new project that's not part of them That's like not a normal thing. But there have been a lot of instances where attackers have done exactly that. They've buried their malicious code in a separate dependency, and then somehow, social engineering or otherwise, convinced a popular project to depend upon that, right? And use that to deliver uh, their delivery system. So that's basically how we do it, and it continues to refine. So that's why we have so many of these that we flag, and the system is able to flag them within minutes of them hitting the public repository, which is pretty cool too.
Wow. Well, and obviously 820,000 humans aren't doing that, right? You'd probably need what, a million people to properly
Right,
vet
right,
820,000 components.
right. So the system is flagging these things. It bulks them all together so our people can look at them most of the time. What's really sad is that while there's a lot of these attacks, not all of them are super sophisticated, and they don't even attempt most of the times to hide their tracks because, like I said, it's more like a smash and grab phishing attack. They don't care if they get caught out in 2 days because they're going to get so many downloads in the first day, and they'll just move on and replicate it. So
Yeah.
it's sort of good news, bad news. The good news is when you do an investigation, most of the time it's pretty obvious on its face that this is just an intentional malware. But for me, that just points to the problem that the ecosystem has not done a good enough job defending against it, because we, in a evolutionary perspective, we haven't forced the virus to evolve. It is basically where we sit at this moment.
Yeah, for sure, for sure. And I feel like everything I am aware of, we are there's not a lot going on in this space, I feel like, compared to what the problem appears to be. And we'll
Yeah.
get to that in a moment, I'm sure.
Yep. Yep.
Okay, so
Yep.
I want to the next graph in your report, or I'm on page 3, only page 3. It like NPM appears to be far and away the most attacked ecosystem here. Where NPM, I
hmm
think you like 540,000, and then PyPy and
Yes.
NuGet and Maven are like undescribable slivers at the very bottom. And I'm curious
hmm
on your thoughts of like, why NPM? What's going on there?
So the PyPy number in terms of relative growth has exploded, as you would expect with, just PyPI in general because of AI. The
Yeah,
number of
yeah.
components has taken off. I wrote about this several years ago, a blog out there, you can find it. It's called Why Namespacing in Public Repositories Matters. And so Maven, for example, uses a group ID. And so like the group ID for Sonatype would be the reverse of our DNS, com Sonatype. We kind of borrowed that from the Java package system. And so the way we manage the repository there is you have to prove that you're Sonatype in order to publish into this namespace. Once you've proven that, then you can publish into any component in that namespace. So org Apache, org Eclipse, Linux Foundation, CNCF, all of these things are vetted and approved. So what that means is it's very difficult for somebody to kind of rock up to the repository and pretend to be someone that they're not, especially when their goal is to pretend to be someone popular or trustworthy, right? Like if I published a random component in the edge of the ecosystem that nobody's ever heard of under my own domain, like if it's malicious, like so what? Nobody's using it. You know what I mean? So these attacks try to mimic a popular repository. Well, NPM in its initial releases had no concept of namespace. So you've lost this ability to distinguish, the publisher, if you will. So it's just an artifact name, which makes it very difficult and also very easy for the attackers to basically create something that sounds similar or is different only by changing a dash to an underscore or vice versa, right? So
Right.
the classic typo squatting is super easy to pull off in these other ecosystems precisely because they don't have a namespace. Um, and so and so that's part of it. The other part of it is those ecosystems, when the component is quote unquote downloaded, on the Maven side, there is no install script. It's just a jar that's being pulled down. It doesn't get executed until maybe when you run your tests or when your application is run, is the first time the code inside there actually gets executed. In these other ecosystems, that's not true. There's pre and post install scripts, kind of like what you see in RPM. So in other words, those package systems are basically remote code execution by design. So you put together, and there's one more piece to this. on the Maven side, when we developed the selection algorithm, it prefers stability over um, ease of upgrade. Now that comes with its own challenges, like the fact that log4j, those vulnerable log4shell versions, still are like 13% of the consumption. So people forgetting to update is a problem. But what that means is, unless people choose to grab the latest, if I were an attacker and I put something out there tomorrow in a new version just sitting there, I don't have like a million downloads happening right away. So it's more likely that people will discover the problem before I get a lot of users. Whereas on these other ecosystems, unless you've locked the version via a lock file, it's going to grab the latest version from the repository, right? So you take all those three things together, it's hard to know that you're getting it from the trusted source. You have remote code execution by design, and you have this prefer the latest, which basically means if I can sneak a thing into the repository, I have users instantly downloading my thing and executing the code. Like, if you were an attacker, what more could you ask for?
Yeah, for sure. And I think there's another piece to it, especially around NPM. Now you can argue this in a couple different ways. The bar of entry for NPM is on the floor. Like anyone can
Hmm.
just create an NPM account and start publishing things like immediately. Now I
Hmm.
also suspect part of the runaway success of NPM is that the barrier of entry is a bar on the floor. So
It is.
there's good and bad
Yes.
there, right?
There is. There is. I mean, I used to get crap from people on socials, around the Maven Central requirements. The namespace validation, the fact that we've always required signing of your components for basically 2 decades. People used to literally say, "Why can't you make it easy like NPM?" And I think now, as people understand the space a little bit, I think they appreciate what we've been doing. That little bit of friction is so far really making a huge difference in what's happening on Maven versus what we're seeing in these other ecosystems. Now, I am constantly paranoid that there will be attacks in the other ecosystem, but for the reasons I've explained, it's much harder to pull off. We know of only essentially one component on the Maven side that has been intentionally malicious, and to me it looked more like a probing attack of the ecosystem because somebody published a component in a made up domain that nobody cares about. It had no downloads, and then somebody anonymously sent me a report that there was a vulnerability in there. So it felt to me like it was a test of our response more than an actual attempt at a malicious component. So
Gotcha.
that will change eventually, but for the moment, it's easy pickings in these other ecosystems. Like I said, the attacks themselves are usually not sophisticated, and they're intended for a very short period of time. That's why I think
Yeah.
a phishing attack is the right way to think about it.
Sure. And it's worth noting that they're not sophisticated today because they don't need to be. When the
Exactly.
bar
That's
gets
right.
raised, it will become more sophisticated. That's just the nature of it, attack versus defense.
That's right. And the fact that the number continues to go up, the number of these attacks, it's accelerating. We haven't seen an approach towards the top, which also tells me it's easy and it's profitable. They
Yeah,
wouldn't be spending their time doing this if it didn't work. It's just like all the spams and all the SMS phishing, the smishing attacks. Why do they keep happening? Because people keep falling for them. It's just
that's
that
right.
simple.
Yes. Yes, exactly. I mean, it's like the ultimate capitalism is, that whole
Yeah.
crime economy,
Yeah.
right? Like they only do what
It it
works.
it it is. And you mentioned this earlier, but I'll bring us there. The frustrating part that I have is that I talk to very smart security folks and I explain this problem to them, and they will say things back to me like, "We have a really good vulnerability management and we have tools that scan before we do a release." And it blows my mind. I'm like, "Literally, you haven't internalized anything I just said. The attack is on your developers. It's happening the instant they install that package. And it's too late. The smash and grab happened. If it was effective, the payload was delivered, and whatever data they exfiltrated is already gone. Scanning it a week later, too late. Doesn't matter. By the way, you might not even see it because many of these components aren't even clones of the real component, so they won't compile. So the developer, will have a build failure. They will realize their mistake. They will fix it. And so by the time it gets into the CI/CD pipeline, where your traditional security scans might happen, you never see that this thing occurred. So you're blind to it on the front, and then the data is already out there. So prioritizing it and defending against it before you release completely misses the entire point. And I think
Yeah.
this is why they're focused on that, because there aren't defenses against it.
And no developer is going to admit they did this sort of thing, even if they know they downloaded something. I mean, the example I always use is many years ago when I was in college. I worked at a factory in the summer to basically pay for beer during the year. But like I had to take forklift training, and I'll never forget. I'm sitting in the forklift training the first day, and the guy says, "If you hit something, what's the first thing you do?" And of course, we're all young and bright-eyed. We're like, "Oh, tell the manager or tell the supervisor or whatever." He's like, "No, you look around and see if anyone saw." And of course, we all got a good laugh. But like, that's literally what happens, right? I mean, it's nuts. Anyway,
and
okay.
and and they may not know, like they don't. We used to see this 2 decades ago, right, with typo attacks on web pages, and the general population didn't know that when they went to a website, whitehouse.com was a popular one back in the day. It was not the White House, it was a porn site. But people weren't conditioned to think, like, when I make that mistake, I might have actually just been hacked, right? I may not have seen it, but they don't think to be suspicious. And we're not yet at that point where the developers, when they realize, like, ooh, I grabbed a component, it wasn't the one I meant to be, to stop and think, why did that happen? And what might have happened on the backside, right? And that's an awareness issue. And
Yeah.
again, these attackers are preying on the fact that nobody responds, nobody realizes it, and it gives them more time to mass distribute this to other victims.
So on page 5, Brian, I'm looking at a graph here, and it says malware attacks blocked by industry. And government is the largest bar. Financial services is number 2, and then it kind of goes down from there. And in the text, it says government organizations saw the highest number of attempted malware attacks, making up 67.31% of, that's very specific, of the total malware attacks blocked by Sonatype. Does that mean like those are customers of yours that you're blocking? Is that what that means?
Yeah, that's right. So the firewall capability that I mentioned before has been augmented with this real-time malware data. And so they can configure in their policy to, if something is marked as suspicious, it will be quarantined until our researchers can validate it, a short while later. So that's where that number's coming from. It's literally the number of attacks that the Sonatype firewall with the malware data has defended against.
Okay.
And it's in the areas you would expect, going after government, going after finance, going after industry with the electricity, oil, and gas. That it's small, 9,676 electricity, oil, and gas as compared to 300,000, but it is still the third largest targeted sector, which tracks with what we've seen in the news, attacks on power plants, attacks on, water, critical infrastructure types of things. We're seeing these as the attempted attack.
Right. Yeah. I mean, I guess that tracks. I don't think I have a lot of commentary there. I will say though, I see the one thing is gambling and gaming is way on the end of your graph. And I've always been intrigued by the fact that I feel like the security of casinos is vastly better than the security of banks, which I suspect it's no different here.
It's not. I mean, that is a sector. Of course, our financial and government is our biggest sector. But yeah, gaming and gambling tools is a good part of it. And yeah, they have money to defend against.
Yeah,
It's interesting when you're defending your customers' data, and there's little downside to losing it because you might have to just buy some people some credit card monitoring at heavily discounted rates. There's little incentive to protect it. But if literally people are like trying to steal your gold bars or the equivalent,
yeah.
You might see the ROI in actually defending against that. That's the sad situation we find ourselves in. Our data is worth nothing except to the attackers.
That's right. I mean, I don't know if it's a sad situation, but it is it's probably it's pretty sad. All right, so I want to finish this conversation on page 8 of it's a 9-page report. Page 8 is titled "Strengthening Defenses Against Open Source Malware." It is a half page. You spent 7 pages describing the problem and then a half page with some suggestions. And I feel like this accurately describes the state of this space. And I'm not blaming Sonatype. Sonatype cannot solve this problem by itself. This is a problem that needs the cooperation of everyone involved. But this is kind of where I would like your opinion. This is very opinionated at this point, but
Hmm. Hmm.
I do not know of any like good suggestions here, and I think your closing helps just affirm the fact that we don't really seem to know what to do here. And like you could tell everyone, oh, everyone should buy Sonatype, but that's obviously that's a non-tenable solution to the problem, right? I think Sonatype is currently the
Doesn't
band-aid.
have to be.
it you know what I mean though? Like and it can't be
I do. I
because
do.
like everyone can't
Yeah.
afford Sonatype. But you know what I mean? Like
Right.
I
So
feel
I
like
do.
what can we even do? And I don't know. And I don't know anyone who has like amazing answers.
Yeah. So I mean, if you look at what we've done at Sonatype with the first the firewall, then adding the malicious data, and you couple that with the defenses that we put around Maven Central, you know, that's my way of solving the problem using the levers that I have access to. And so I think for our ecosystem, we've done a good job defending against it so far. Like I said, the future, where we're constantly paranoid, we're constantly on the alert for this, and I'm confident we'll be able to keep on top of it. For our customers and our products, we've done ways to defend against this. Because it's a new and novel type of attack, the only way to actually defend against it is to stop it before it gets delivered to the developer machine. So you need a mechanism in the middle. You need a firewall with the ability to detect that the thing being downloaded is also malicious. And this needs to happen within minutes of these things hitting the repository because, like I said before, the ecosystem prefers the latest. So as soon as it hits it, you're starting to see downloads like nearly instantly. So you need a system that can understand that something is malicious. You need a system that can intercept that so it can see that it's happening and then stop it before it lands on the developer system. The way we've rolled that out currently is to sit on the repository managers, Nexus Artifactory, and it's quite effective. But we know that not everybody can or will enforce all of the downloads through repository managers. So we're looking at other ways to do that, whether it's integrations with endpoints or actual network firewalls. There's a key to having the data to know that something is vulnerable, and I think we do a good job at that. So that's one part of it. Like you need those tools to be able to do it, and so far there aren't any other than what we've developed. In terms of the ecosystem, again, I wrote that blog and I can send you the link because I think it's still as relevant now as it was back then.
Yeah, for sure.
That
I'll put
kind
it
of
in the show
provides a
notes.
roadmap. Yeah, I think it's really useful because it outlines those three things with examples and some history behind them about the namespacing and the other things. Those are things that are up to the repository package maintainers to manage. And some of them are, I would say endemic to the ecosystem. The fact that NPM launched without namespace, they added it later, but it's not required. You know what I mean? And probably to require it now would be a massive upheaval to that ecosystem. I'm not aware of the consequences of big changes here, but that's the type of stuff that I believe is required to make these changes. Now, I've seen, and we might have to fact check this. One of the two ecosystems, maybe both, NPM and or PyPI, recently made a change so that the install part of it won't execute automatically. So that addresses one of those three things that I was talking about. But I think this is where education of developers come into play because everybody's just going to hit the yes or the -F flag to say just do the old thing anyway. So the ecosystem has started to make some changes in at least one of those instances to remove one of these paths that are creating this problem. So yeah, I think we could have expanded this page in retrospect more because I have written about it a lot. We spent this whole time talking about it. I know how broadly to fix this problem, but getting everybody on board to actually solve it is a much harder challenge.
For sure. Well, and I think this is also related to your comment about our data is only valuable to the attackers. Like, in all seriousness, NPM suffers very little when someone uploads malware to their repository, then it gets downloaded. And so there's also the incentives are quite bad here. And not to knock any of these open source ecosystems, but the vast majority of them are like running on shoestring budgets. And, they're doing their best with what they have.
absolutely. I actually meant, software manufacturers in that
Sure,
comment
sure.
that, this gets into the whole software liability thing, which I think we talked about last time, right? Until we change sort of the dynamics for software vendors, that there's a
Yeah,
big downside to them losing our data, they're not going to see the ROI appropriately to invest in solving this problem.
100%. Yes. Yes. Exactly. I mean, incentives, man. Like, we need some.
Yeah.
All right.
Yeah.
All right, Brian. It has been a treat. You've given me a lot to think about. I truly appreciate the time.
Yeah. Thanks for having me.
Awesome. And I'm sure you'll be back soon to talk about something else. So, talk to you soon, man.
All right. See ya.